I can't find this.
Do you feel a little better looking at that? Remembering like, oh yeah, I do remember that.
That makes it feel worse, Miss Lyle, because you know we're supposed to know how to do it.
Well, I know, but that's what I'm very proud of you, that you keep your notes, and many of you were able to find them. That's a beautiful thing.
Oh, yeah.
But I just can't find it.
Oh.
Can you turn the lights on, please?
But those were.
Okay, what? No, it's only when you turn the lights on that it hurts you. Not when you turn them off. Okay. Wait, what did she say? Watch your eyeballs when she's turning the lights on. Does it hurt your eyes?
A little bit.
It's mine. Okay. I'd like to get through these quickly because I'm hoping we're going to continue doing some work. I'm not going to give you any new information today. Brad asked me to give you the information about the remainder theorem so that that can be in your notes. And then we need to be done at a reasonable time. Okay, so you were asked to solve by factoring. And I noticed that what is a common factor? X. So I just pulled out the common factor, and I had x squared minus 3x minus 10. And again, knowing how to factor helps here. What are the factors of 10? So I'm going back to what are the factors of negative 10 that when combined, the sum will be a negative 3x. And I could see that it was a negative 5 and a plus 2. So when I'm solving for this, remember, this is going to equal 0. Is it possible that this is the term that's the 0? Because if this is 0, 0 times this quantity will equal 0. So remember, that's what we're looking for. We're looking for where the graph crosses the zeros. Okay, so I know that x could be a 5 or x is a negative 2. Okay, are you with me, Stephen? I see you fiddling around with that, but are you listening?
I am. I'm trying to get it on the screen.
All right, and then I'll do number 3. And number 3 was the same deal. I just thought, what are the factors of a negative 4 that will give me a negative 3, and I could see that my factors were 0, x is 4, and x is a negative 1. Okay? That makes sense to you? Yes.
Then I also had a question on number 9 because
number 9.
Yeah, because when you got it, you got x and x squared up there, but then when you multiply 3 by x squared, it equals 3x squared, but you can't subtract that from 13x.
Okay. Now, could you write this number down for me? I'm going to just dictate a number. Write the number 104. 104. What does that number mean?
104.
You have 100.
Plus 4.
How many tens do you have?
10.
1. 0.
Oh, that's 100.
104.
Well, you do have 10.
You have 100. We have 0 tens.
Oh.
And how many units do we have?
4.
4. Why do we have a 0 in this case? It's a what, Avery? It's a placeholder. Because if you didn't have a 0 there, and you just wrote this, this says, well, I have 110 now, and 4 units. We use 0 as a placeholder to keep the 1 in that place. Does that make sense? Everybody good with that? All right, well, let's see what happens when we divide. Here it is. Okay, so the number was x cubed. I'll write it out actually. So I had x cubed minus 13x plus 12. Was that the original number? And I was dividing it by what? X minus 3. Okay. So I'll just cover up the other problem for a second. Okay. So I'm going merrily along, and I know that I have to multiply this by what? X squared. But it's like, where am I putting it? I have no x squared, it's gonna kinda like get jammed in here. So I have x cubed minus 3x squared. Okay, so I see, I need a placeholder. And can I do a placeholder by adding 0x squared? Because 0 is just,
Oh.
yeah, well, it's still going to be nothing, it's just a what? Placeholder.
X squared minus 3x squared. is
Okay.
different than-
Pardon me?
X squared minus 3x squared is different than, like,
Like
just
zero
nothing
X
there.
squared.
But there is a 0 here, I just added a 0.
Right.
That's all I did, just like I have a 0 here, it's just a placeholder. Because
Yeah.
what is 0 times, if I said to you x is
Yeah.
2, what is 0 times 2 squared? It's gonna be 0, right?
Yeah.
So it's just holding a place. And by doing that, can I then say, oh, there I go, x squared times x gives me x cubed minus 3x squared. I was gonna subtract it, so now I'm adding it. And so I will have
3x squared
3x
subtract
squared,
13x.
and then I can continue
Which
as
one?
usual. That was number 9, I think. Does that make sense to you?
You studied it anyways.
Did you? You didn't think about it, but you did. That's called intuition.
I
I really
figured out
mess
how
up
to do
the
it without
plus and minus
adding it, but it
form.
ended up just shifting over the things on the top.
That's all. Not a big deal. I mean, if you can do it without it. It's just, you need to think about it.
Yes.
I'm sorry? What was the
Zero.
final, the remainder was 0.
Zero.
The remainder
Okay,
of
did you get a 0 for that?
the one we just did? Oh, no, not yet.
Number 9. All right. Any other questions then on those?
Was
Yes,
there?
no?
Wait,
What?
I didn't exactly something. But when you're getting it up on top, and you know it's full.
Which problem we're talking about, Michael?
I don't know, just in general.
Okay,
Can
in
you-
general.
So make a number negative, so then you don't have to switch around the signs at the bottom. Like if you are trying to get like a positive 28,
Let's look, do you have number, let me see. We were doing the evens, right? Do you have number 12 there?
yeah, well, can you get a negative, so then you don't have to switch around the signs?
9, 10. Do you have number 10?
Do I have to?
Yeah.
Yeah.
Okay, let's do number 10 together. Okay, so I'm starting with, if the reason why you have to be careful, Michael, is because what I'm trying to do is I'm always trying to eliminate this first term. So x squared times x is x cubed, right? And x squared times a positive 3x is a positive 3x. But what I'm doing is, and this is the same, I'm asking, how many of these fit into that? And now it goes x squared times, but I'm then subtracting. And that's, so it was a positive times a positive is a positive, but I'm taking that out. So it was positive, but I'm subtracting, so it becomes a negative. These cancel out. This was a positive, I'm subtracting it, so this becomes a negative.
Okay.
Okay? And that's the division process.
Yeah.
Okay? If I said to you, how many times does 4 go into 26? Well, 4 goes into 26 6 times. I'm subtracting. How many is left over?
2.
2.
Right, but you see how I subtracted. 4 times 6 is a positive 24, but then I'm taking it away from what is there.
Why can't you multiply it by negative 6, so then you don't have to switch around the signs?
Because it is not a negative, my answer isn't 4 times, because remember, the quotient, well, I'm sorry, the product of 4 times 6 is 24. Well, you can't have a negative in there. You can't say it's 4 times a negative 6.
Okay.
Stephen?
Would it be possible to work backwards and multiply 6 remainder of 2 by 4 to get 26?
Oh, yeah, absolutely.
How?
Well, 4 times 6
Oh.
is 24, add 2
Oh, never mind.
is 26.
Stupid question. Okay.
Absolutely. Okay. All right. So, all right. Any other questions, Laura?
For the 15, 17, and 19,
15, 17, 19. Hold on. Yeah.
if the numbers are negative, do you plug it in as a negative number, or you just plug it in?
Okay. Good question. Okay, Michael, let's listen to the question, please. Okay, so for number 15, we were dividing it by x plus 3. Here it is. So I am plugging in the opposite. So why don't we, I'd like to give you these notes, and that will explain why. I believe,
Just, we only have like 2 minutes.
I know. Here you go. Here's the remainder theorem. Yes. Okay, so the remainder says if we have a polynomial, whatever the polynomial, is divided by this. Remember, this is a factor. Where a is a constant, then the remainder is going to be p of a. Okay, so in the previous example that we just did for number 15, wait a minute. Sorry, not, I'm on the wrong side. 15. Oh, so in 15 it was x plus 3. Well, it's supposed to be my x minus, what must a have been to make it a positive?
Negative.
Had to be a negative. So that's what we're plugging into our function. So it would have been 2x cubed plus 4, what did I say, minus 3 squared, minus 3x plus 5. All right, hold on a second. So, all right, I was going to give you homework tonight, not due until Thursday because we're having the chapter test, but if that's okay with you. Chapter 7. Okay, so study the 2 quizzes and those worksheets, and that's what it is. It's chapter 7.